Well, hello everybody. What I'd like to do with you today is I'd like to cover section 3-1 with you. I'm hoping that you did well on your test, or if you missed class, this is the lesson that you missed. But what we do today is I need to review with you some Algebra 2 items, talk about the parent functions, their domain and their range. And then where I'll really slow down a lot today is I'll make sure that you understand how to graph some functions that's coming up with us that won't be on a restricted domain like we've been doing in Chapter 2. So what you need in front of you, you need your class notes in front of you. And you should have at least a little white piece of paper, if not a pink note card, that has our 9 parent functions on there. Because what we do in this chapter, we work with those parent functions quite a bit. We move them, we translate them, we change them, we vertically stretch them, we compress them. Things that you did last year in Advanced Algebra 2 called your purple note card. But look at your piece of paper. You can add some notes to that if you want, but I'm going to bounce around a little bit on these parent graphs. So the first one I'd like to talk to you about is your absolute value function. Remember, the absolute value function looks like a V. It's a continuous function, meaning you can draw that graph without picking your pencil up. So in this case, our domain is -infinity to infinity. Our range is going to be 0 to infinity. Starts down here at this vertex and then moves up. There's no asymptotes on this one because it's a continuous graph. The next one I'd like to talk to you about is the cubic graph. You might have also called it the snake graph last year. It just has that little curve in the middle. We can beef it up and you may see more down the road, but for today we just want to talk about the parent graph of it, and then we'll start changing it down the road. So the domain and range on this. The domain is going to be, once again, -infinity to infinity. The range is also going to be -infinity to infinity. There's no asymptotes on this either because the graph's a continuous graph. I can draw this thing without ever picking up my pencil. The third one I'd like to talk to you about is the exponential graph. We've already graphed that one back in Chapter 2. Remember the domain of this? -infinity to infinity, because you can plug in anything in there for x that you want. Now the range is 0 to infinity. Remember, this thing did have an asymptote on there. It's the equation y equal 0. Moving on down your note card. The piecewise function. It's a little different. Remember, it's just a step function. So your domain is still -infinity to infinity because you can plug in any x value that you would like and you can round it down to the nearest integer. Now the range is a little bit different on this one. What the range is, it's nothing but the integers. So what I'll say for the range is, I'll say that it's the all integers. There's no asymptotes on this one because our graph's not approaching a certain number. So I'm clicking through these a little bit because I'm hoping this part will be review for you. Then I'll slow down on the graphing part of it a lot. I'd like to talk to you about the hyperbola also. There's the parent graph of the hyperbola. Notice that there's an x in the denominator. So I cannot allow x to be 0 because 1 over 0 is undefined. So your domain is going to be -infinity to 0 along with 0 to infinity. So everything but 0. The range is going to be the same thing. I'm going to come from -infinity to 0, but then I'm going to go 0 to infinity. So -infinity to 0 along with 0 to infinity. Now this thing has 2 asymptotes. We have the x-axis and the y-axis. So I have an asymptote at y equals 0, and then I also have one at x equals 0. Now, this graph is not continuous. Continuous means you can draw it without ever picking up your pencil. This one, you draw a piece, you have to pick up your pencil and do the next one. So that's what we mean when we say continuous. Let's look at the line y equal x. We usually don't think about the line y equal x being an identity, but it is. Its domain, negative infinity to infinity. Its range, negative infinity to infinity. No asymptotes on this one, because it goes up forever, down forever. The inverse square variation we touched on a little bit back in chapter 2. Notice the domain. Once again, you can't allow a 0 to show up in that denominator, because then I'm going to get 1 over 0 again, which is undefined. So your domain, negative infinity to 0, along with 0 to infinity. Your range in this case, notice that it never goes below the x-axis, so my range is going to be 0 to infinity. Now, just like the exponential, this has an asymptote or two. I've got 1 being the x-axis again, and then I've got 1 being the y-axis. So my two asymptotes, the line y equals 0, the line x equals 0. The parabola we did last chapter 2. We talked about it being a quadratic. Remember its domain, negative infinity to infinity. Its range is bracket 0 to infinity, because I can include 0. Asymptotes, there's none. And then the square root function, it's a little bit different. Remember, the square root function starts at a starting point, and then it goes in a direction, in this case to the right. Your domain is 0 to infinity of this, because I can take the square root of 0 and get an answer. We throw away the negative numbers because we can't take the square root of a negative number until we work with the imaginary set. The range in this case is also 0 to infinity. Now, there's no asymptotes in this one because it doesn't approach a number. It just starts and then goes. So that takes care of our parent functions that I wanted to kind of review with you. Now, what we do from there is we take those and we move them, we translate them, we stretch them, we compress them. So here's where I'll slow down a little bit. What I'd like for you to do is graph the absolute value of x plus 25 minus 10. So guys, in your calculator, in case you don't remember how to get to everything, in your y equal, to get to the absolute value, remember you go math over to number, and then the ABS is your absolute value. Now, my calculator turned it into the absolute value symbols. Some calculators do not. It'll leave it as an ABS. So just know your calculator. But guys, there's what I'm going to graph. Now, the trick part of this is we want to try to center this graph. I will also tell you this, there are a ton of ways for you to graph this today. I'm just going to show you a couple and kind of get you thinking on them just a little bit. But things that I want to do, and I'm going to come back and grab my calculator here in a little bit, but things that I want to do, we want to try to center this graph, if possible. It doesn't have to be perfect. The other thing that you want to do, you want to see all the key features of the graph. What do we mean by key features? That would be any x or y intercepts that our calculator gives us. It would be any maximums or minimums. Could be the vertex. Anything that's critical on your graph. Now, I'm going to review some things with you from your Algebra 2 days a little bit also. Notice, guys, when I come back to my calculator, if I just go ahead and hit graph on this, right now I'm in Zoom 6, notice that I don't see much. some things that I know I should see. I should see a V-graph. That's what I should see. Now, some things that I know is going to happen. This V-graph has been translated. See this x plus 25 inside your absolute values? That's going to move it 25 units, but to the left. So this thing's going to be translated 25 units to the left and down 10. So when I'm come back in my calculator here, I need to start playing with some numbers here. I'm going to try to find a good window. So I'm going to come into my window and I'm just going to toy around a little bit. I know I need to get to at least negative 25 on the x-axis. So I might try negative 30 and I might go to 10, and then you can count by right now whatever you want to count by. Now, one convenient way, if I go from negative 30 to 10, that's 40 units. I'm going to divide that by 10, and I'm going to count by 4s. Now, I also know it's been shifted down 10 units, so I'm going to give my y a little more room to grow. Now I'm going to see if this helps any. Okay. Hey, notice that it helped a little bit. I now see one x-intercept, I see a y-intercept, I see the vertex, but notice that I don't see over here. So I need to give the x some more room. So I might go to negative 45. And I might just see if that helps any. Okay? So there I've got a little bit better. I've got a little bit better. Okay? So here's what I've got going so far. If I look at my window, I went from negative 45 to 10, give or take something. Right now my y's are going from negative 20 to 20. Now, let's look at your grid real fast. Notice that I don't need much room over here. So let's decide what I really want to count by. I'm going to put my x-axis way over here. I'm sorry, my y-axis way over here. So let me grab my line tool and let me draw my x-axis right there. Now, I don't know where I'm going to put my y-axis yet. Okay? So now, here goes my thinking. Since I put my x-axis way over there, I'm going to let this represent 5. Now, let's see where I would be to the other side. 5, 10, 15, 20, 25, 30, 35, 40, 45. So far on my x, I'm going to go from negative 45 to 5 on my window. So my x window, I'm going to say, is negative 45 to 5. And I'm counting by 5s. Now, you could have done so many other different things. Now, I'm going to go ahead and put my y-axis kind of right smack in the middle. So I'm going to go right here with my y-axis. Now, let's go ahead and label your grid. So this is going to go from 5 to negative 45. Decide what you'd like to count by on the y's. I got to make sure I get the y-intercept. So I'm going to come back into my calculator and I'm going to go trace 0. I need to make sure I cover at least 15. They make sure I cover at least 15. Well, I can get that if I count by 5s also. So 5, 10, 15, 20, 25. 5, 10, 15, 20, negative 25. Now, let's get all the features of our graph now. I know this is a V-graph with the vertex at negative 25, negative 10. So 5, 10, 15, 20, 25. So there's negative 25, 5, 10. So there's my vertex. I know it's going to cross the y-axis at 15. So 5, 10, 15. The other thing I'm missing now, guys, is the x-intercept or where it crosses at 45. So I can go get real fast. I'm going to also graph the line y equals 0. Let's go second, calculate intersection, and let's see where my x-intercept is. Enter. So it looks like it's at negative 35. So 5, 10, 15, 20, 25, 30, 35. Now, I've got everything I need to graph this now. I know it's a V-graph, so there's one piece of it. There's the other piece of it. And since this goes on forever, let's put our arrows on there. So guys, that took just a little bit, but the moral of the story, you pick your own scale. If every one of your scale looks like my scales, something sounds fishy. Kind of like you used our answer key a little bit too much. Our scales can be different. You just make sure your graph fits. Make sure it does all the features, y-intercept, x-intercepts. Okay? So let's go to the next one. I'll try to pick the pace up a little bit on this one. If you would, come in and let's graph the square root of x minus 8 plus 5. So second square root, x minus 8, get out of that, plus 5. Now guys, some things that I know. Let's go ahead and zoom 6 this so I can get back to our normal. Okay, notice that I'm way over here. But let's pick on some things that I know. I know that this is going to look like the square root graph. I know it's been translated 8 units to the right because of that minus 8, and then it's going to be translated 5 units up. The other thing that I know from not looking at my graph, there's no y-intercept and there's no x-intercept. So all I got to do is make this thing fit. So you decide where you'd like the scale. Now, I'd like to try to put 8, 5 somewhere in there. Somewhere in there. So we'll just try to figure out where that might be. So like I said, a lot of different options. Notice that when you look at your graph, I don't need anything over here. So I'm going to set my y-axis way over here. I'm going to set my y-axis way over there. My thinking, if I count by 2's, there's 2, 4. There's 2, 4, 6, 8. So there I've kind of got it in the middle. Now notice you got to go up at least 5. When you look at your graph, there's nothing down here. So you don't need much room underneath the y-axis. So I'm going to set my y-axis way down to here. So now let's decide what kind of scale I'd like to use. If I count by 2's, there's negative 4. If I count by 2's, 2, 4, 6, 8, 10, 12, 14, 16. So far for my window, on the x-axis I went negative 4 to 16, and I counted by 2's. That's not the only way to do that. Now on the y's I need to cover at least 5. So 1, 2, 3, 4, 5, 6, 7, 8. So I could count by 1's. I could count by 2's. That part doesn't matter. I'm going to go ahead and count by 2's. So this would represent negative 4. This would represent 16. Now, I'm ready to graph this, guys. I need to go over 8 and up 5. So 2, 4, 6, 8, up 2, 4, 5. So there's my point 8, 5. Let's keep this simple. I'm going to go trace, well, I'm going to change my window a little bit. I'm going to go from negative 4. I want to cover at least 16. So I'm going to do that. The reason I'm going to do that is I need one more point to make this look good. So I'm going to go trace 16 and see what I get. Looks like I got about 7.8. So at 16, let's graph about 7.8. So 2, 4, 6, 7.8. So not quite 8. And we know this is a square root graph, so here goes our graph. Okay. This one was kind of easy. I didn't have to do any special features or anything. No x-intercepts, no y-intercepts. So there's my graph. My window, my y window, I decided to use -4 to 16 also, counting by 2's. Like I said, guys, there's a lot of different ways to do this. So what you see here isn't the only way. You just make the graph fit. You just make the graph fit. Let's come over to your third one. I've got h of x equal -4.9x squared plus 4.5x plus 4.7. I hope you kind of recognize this one because you have a note card for it. This is part of Newton's law. Now, some things I know about Newton's law. T stands for time. So in this case, x stands for time. So I can't have negative time. So when I come in to graph this, let's go -4.9x squared plus 4.5x plus 4.7. Now, notice that when I graph this, I've got that. So I'm going to go ahead and zoom 6. Now, remember, time is negative, so I don't need much over here, guys. I really don't need anything at all. I'd like to get this to fit. So some important things on this graph. I need to find the vertex, and I need to find that x-intercept. Two ways to get the vertex. You could go the opposite of b over 2 times -4.9. There we go. Wasn't right in there for a second. 2 times -4.9. And if you run that through your calculator, you're going to get about 0.46. Now, I could do this in my calculator now. I can just go trace 0.46, and I know the vertex is about 0.46, 5.7. So my vertex about 0.46 and 5.7. So I need to make sure it covers at least that. Some other things that I need the y-intercept. So trace 0. So I need to make sure I get 0 and 4.7 in there. So I need to make sure 0 and 4.7. The other thing that I need this x-intercept. So let's go second, calculate the intersection. Let's get over to that. So it looks like approximately 1.54. So I need a x-intercept at about 1.540. So we need to make sure all of those things fit. Remember, I don't need any negative numbers. So what I'm going to do on this one, I'm going to go ahead and put my y-axis maybe way over here. I don't need much below, so I might put my x-axis maybe right there. So now let's decide what to count by. I need to get up to at least 5.7. So 1, 2, 3, 4, 5, 6, 7. So I can count by ones on here if I'd like. So that would be -3. That would be 1, 2, 3, 4, 5, 6, 7. Now, picture what you need on the x. On the x-axis, you need to get to Just 1.54. Just 1.54. So I'm going to count by halves on this just to spread it out. So that would be -1. This would be 1/2, 1, 2, 3, 4. If you chose to count by ones, big deal. So now here goes the graph. I need to make sure I get 0, 4.7. So 0, 1, 2, 3, 4.7. There's my y-intercept. I need to get to 0.46 and 5.7. Now remember, I'm counting by halves. So almost there, and then up to 5.7. 1, 2, 3, 4, 5.7. There's my vertex. My x-intercept is at 1.54. So there's 1, 1.5, so right about there. So here's what my Newton's law is going to look like in this case. Now, I went ahead and let Newton's law go below the x-axis. The reason being, somebody jumps off of a cliff into water, they're going to be below the surface there. So it's okay there. It wouldn't be wrong if you continued it off over here. That just means you didn't recognize it as Newton's law. So guys, the window that I decided to use on this one, my x-axis was -1 to 4. I decided to count by 1/2. My y-axis was -3 to 7. I decided to count by 1s. Okay. So guys, that's all we got going on so far. Here comes my last one. We're going to graph 1 over x minus 5, where x cannot be equal to 5. So when we type that in, we got to go 1 divided by parenthesis x minus 5. I'm going to go ahead and hit zoom 6 again. So notice that we get something with an asymptote in there. Now let's talk about the asymptote for 1 second. Notice this x minus 5 in the denominator. We can allow 0 to show up in the denominator. So I know this thing has a vertical asymptote at x equal -5. Other little key features on this, let's go get the y-intercept. That's easy. We'll go trace 0 and get -0.2. So another thing I know, I got 0, -0.2. Now, this thing doesn't have any x-intercepts, and it doesn't have, well, no x-intercepts. So now when we draw this, notice guys, I don't need much over here. I don't need much over there, but my grid looks pretty good in the middle. So I might draw my line, my y-axis, I may draw it way over here. And I may just run my x-axis right down the middle. Now, let's decide what you'd like to count by. I don't have to get a ton in there. I do know I have a vertical asymptote at 5. So if I count by 1s, 1, 2, 3, 4, 5, I've got a vertical asymptote right there. That wouldn't look bad. So I may count by 1. So there's 5, 6, 7, 8, and -2. Now, let's draw that vertical asymptote. Let's draw that at 5. So 1, 2, 3, 4, 5. There's that vertical asymptote. It happens to be at x equal 5. We know we got 0, -0.2. So 0, -0.2, way over there. And I guess it looks like I'm also counting by 1s on the y. I about left that off. So let's count by 1s there. So I've got enough to draw one of my branches. But let's be a little more exact. Let's come into your calculator. Here's x equal 5. Let's get a point on each side of the asymptote. So let's get a point right there at 4. So let's go trace 4. So it looks like at 4, I'm -1. And then let's go trace 6. And those worked out nice. So at 6, I was at 1. Now, that's all we need to graph this. So this graph's going to approach the asymptote, hit that, approach that asymptote. This graph's going to do the same. Going to approach that asymptote, go through that point, and there's what our graphs look like. Okay, so guys, that's our graphing unit. My video took 30 minutes. My goal was 25, but if you would, finish up that packet that we gave you. If you have any questions, pop in. Miss Dinahan and I will get you straightened out. Good luck.